Good morning to everyone. I feel immense pleasure to be here again for my course Aircraft Systems. Today I am in lecture number 32. My topic of this lecture is fuel tank and its safety. As you know that I am Dr. Yagyadat Dwivedi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have covered Module 1, Module 2, Module 3 of the 6th semester Aeronautical Engineering or 18 batch. And I have seen that I have covered Module 1. In Module 1, the different fuel systems are mentioned only introduction type, like the structural system, vehicle system, avionics system, and the mission system, and brief introduction of each systems are given. In Module 2, if you see, we have seen the aircraft electrical system. In that, we have seen the power generation system, AC and DC, power distribution system, power storage system, emergency power system, power safety mechanism, different types of voltage and the hertz, 400 hertz application, its advantages and disadvantages. These things in Module 2 we have covered. In Module 3, we have seen the hydraulic system, pneumatic system. In that, what are the components required for hydraulic systems, their safety, their hydraulic fluids, their properties, advantage and disadvantage. Also, we have seen the pneumatic systems, their components, need of the pneumatic systems, their advantages and disadvantages, and these things I have covered. In Unit 4, I am just about to end. One more class is there. In this, we are talking about the engine control and the fuel control. Engine control I have covered, and I am in the last phase of the fuel control system. Before that lecture, I have already discussed different types of jettisoning, refueling, defueling, and so on. I have already done, and FIDEC we have already covered. In today's class, I am going to talk about introduction of this fuel systems, type of fuel system components, fuel tanks, fuel grades, fuel safety, and the precautions to be taken for this fuel system. So if I talk about the introduction, fuel is like a blood. Like blood for human, fuel is for engine. The power is given by the fuel only. If fuel is burned, then only you are going to get the power. Okay, so these few topics I have already covered in the previous class about different fuel systems, their design criteria, their different types of pumps, their advantages and the disadvantages, and so on things I have already covered. Now I will go with the introduction of the fuel system. So the fuel system is one of the most important system in an aircraft, and its purpose to stores, manages and supplies the fuel to the aircraft engine. The aircraft fuel system supplies a proper amount of clean fuel at all operating conditions to the engine. Fuel system must be so designed such that it supplies a proper amount of fuel to the engine at various phases of the flight, such as changes in altitude, rapid maneuvering, sudden acceleration or the deceleration. The fuel systems means a complete package of equipments which help from storage of fuel up to the delivery to the tank in a proper way. That is fuel tank, fuel pipelines, valves, fuel indicators, fuel pressure pumps, warnings, signals, etc. A fuel system should always be free from tendency of the vapor lock. Vapor lock means the air should not be trapped inside, or the vapor which is generated above the tank, it should not be locked. That is the tendency. The fuel system design construction and component selection vary from aircraft to aircraft. A lightweight single engine aircraft will have simple or box type fuel system, whereas a heavy aircraft with twin engine will have a complex fuel system such as integral type of the fuel tanks. So here I will talk about the types of fuel systems, and in this we will see that generally the fuel systems are classified into two broad categories on the basis of method to supply the fuel to engine. In a small and the light aircraft, generally gravity feed fuel system is used, while a large turbine engine aircraft pressure feed fuel systems are used. Okay, so basically we have the two types of the fuel system. One is the gravity feed fuel system, another is the pressure feed fuel system. For the large turbine engines, we use the pressure feed, and for the small engine, piston engine, we use the gravity feed fuel systems. First, I will see about the gravity fuel system. This system makes use of the force of gravity to deliver the fuel in the power plant from storage tanks. It is most commonly used in high-wing light aircraft, in which the engine is located below the main wing. As a result, below the fuel tank, as the fuel tanks are generally located on the main wing. This is the simplest and the cheapest mode of the fuel feed system, as no additional complex components are used and uses only the gravity force. The main disadvantage of this system is it is affected by the vapor lock which stops the fuel. This is the big problem and big challenge on this type of system. Fuel to flow through the pipelines. Now, gravity fuel system of the Cessna 172S, a very simple aircraft, and here we can see that these are the tanks. This is the left and this is the right I am writing. These both tanks are connected with a fuel selector valve. This I have shown in the previous class that the fuel selector valve will select both tanks, select one tank left or right, shut off, act as a shut off. This valve, if you open, this can go from this side also, from this side also. If there is some problem, it can disconnect either this or this, only one side it will go, and if you want it will close, no fuel will go. So this has got these functions. Okay, so this is the purpose of your shut off valve or the fuel selector valve. Fuel selector valve is acting as a selection from the tank 1 or tank 2 or both, and it is also closing both the tanks in case of any emergency in the engine. Then we have a fuel reservoir. A small tank is here. It is called the fuel reservoir. A small quantity, few liters, it is kept here. This will give a positive feed to the other, and fuel is filled everywhere so that there will not be any type of problem, any type of corrosion or any type of moisture is not trapped inside the pipeline. Then we have the auxiliary fuel pump. It is a booster pump type of thing. This is a booster pump. Auxiliary pump, a small feed is given to the system so that the moisture from the atmosphere should not be able to enter inside the system. Then we have the fuel strainer. It is called the filter, fuel filter. It is maybe Curtis type or some different types of fuel systems are there. Engine driven pump, it is called EDV. It is a high pressure pump is here, and if the fuel quantity extra, it will be bypassed and it will go to the check valve, and from there it will go here. From here it will not go. Only one side. From here it goes to the fuel distributor, and here it will go to the injector, and for the piston 1, piston 2, piston 3, piston 4 and so on, it is distributed. So this is a simple gravity fuel system of the Cessna 172S. Now I will talk about the pressure feed fuel system. In the previous one, gravity, we are not using any pumps or anything, and it is just supplied by the gravity. But now in the pressure feed system, we have to use a pump. Most of the aircrafts are designed such that engine is mounted above the fuel tank, or for example mid-wing or the low wing configuration of the aircraft, or the engine is far away from the fuel tank. In this case, the gravity fuel feed systems cannot be used, and therefore a need of positive pressure is developed. So if the engines are mounted above the wing, or the engines are far behind or far ahead from the wing or from the fuel tank, that time gravity systems may not work, and it is not very efficient also. That time we have to use some pressure pumps, and this pressure will give a pressurized fuel to the engine. So in this case, the gravity fuel feed system cannot be used, and therefore a need of the positive pressure is developed to supply the fuel in adequate amount to the engine. It generally makes use of 2 electric pumps for the feeding of the fuel into the engine. As stated above, the fuel system and its components vary from aircraft to aircraft. The use of 2 electrical pumps in the most basic method used. The complexity of the fuel system increases with increase in aircraft size. A large transport aircraft or a maneuverable combat aircraft. Pressure feed system I am going to discuss here. In the pressure feed system, your tank is below the engine. Here it is shown, and from here there is a feed pump. It will give pressurized. From here it will go to the fuel filter. From this fuel filter, this will go to the fuel pump. From the fuel pump, the red line will go to the high pressure, and this will go to the high pressure pipe, and this will go to the injection nozzle. And if the excess fuel is there, it will be returned in this direction, return pipe. And if excess fuel is there in this pump, it will also join. And if the excess fuel is there in the fuel filter, it will also join. So all this blue color is all return line, and the red color is the high pressure line, and this yellow color is the low pressure unfiltered, green is the filtered, and the red is the high pressure line. In this way, the pressure feed system is working. Another Beech Bonanza K35 fuel engine, and the previous one was the Cessna. So here, if you see here, legends: fuel supply, fuel return line, fuel tank vent. So if you see this dotted line, these dotted lines are the fuel return line, and the double line is the fuel vent line. If you see here, we have the 4 tanks, 2 are the main tanks and 2 are the auxiliary tanks. These tanks are fitted here with check valve, means it will not allow fuel to go in this direction. Only in this direction is permitted. Here one shut off valve, here is the check valve. From here it goes to here a engine, and here is the fuel selector valve and strainer. Selector valve means left main wing or right main wing. It will select. It can also select the auxiliary tanks. Then it will go to the check valve again. Here we have the auxiliary fuel pump, fuel selector valve and the strainer. Then it goes to the fuel pump, and from here it goes to the engine for the different piston engine configuration. Fuel system component, I want to discuss what is the function of each and every fuel components. So first is the fuel pump. So fuel pumps are used to supply fuel through the system. Their main another are from engine back to the tank. Basically, we have the three types of fuel pumps are used. Vane type pump, it is a constant displacement type pump, uses a rotor which turns the vane in the cylinder, and these vanes act to push fuel through the system. Centrifugal boost pump, they are used to supply fuel from one tank to other or from tank to engine. Centrifugal pumps are electrically driven and can operate at different speed as per requirement. Low speed is used to supply fuel while starting, and high speeds are used to supply fuel from one tank to another. Then we have the injector pumps. Ejector pumps are normally used to eliminate fuel from remote areas. Okay, I have shown the previously, I think you may be remembering in my previous class that we have used the ejector pump, and these ejector pumps are used to suck the fuel which are entered in the previous system. Now I am showing some fuel pumps here. This you can see here, a booster pump, a small pumps. Here we have the balance line, we have the pump outlet, we have the inlet here. Fuel is entering from here, fuel is going from here, and there are some pressure relief valve and other valves are fitted. Here we have this Venturi type, the ejector valve, ejector pump. This is called the ejector pump. Here we are using the Venturi, and this Venturi is creating the high pressure. Here we have the centrifugal fuel booster pump. So 1, 2, 3, three types of the fuel pumps are shown here. Now I will discuss about the fuel tanks. Aircraft typically use three types of fuel tanks: integral, rigid, removable, and the bladder. So integral means they are fixed. Integral tanks are areas inside the aircraft structure that have been sealed to allow fuel storage. An example of this type is the wet wing, commonly used in larger aircraft. Since these tanks are part of the aircraft structures, they cannot be removed for service or inspection. Inspection panel must be provided to allow internal inspection, repair, and overall servicing of the tank. Most large transport aircraft use this system storage fuel in the wing, belly, and sometimes tail of the aircraft. Rigid removable tanks are installed in a compartment designed to accommodate the tank. They are typically of a metal construction, and they may be removed for inspection, repair, replacement. The aircraft does not rely on the tank for structural integrity. These tanks are commonly found in smaller general aviation aircraft such as Cessna 172. Third one is the bladder tanks or fuel cells, are reinforced rubberized bag installed in a section of the aircraft structure designed to accommodate the weight of the fuel. The bladder is rolled up and installed into the compartment through the fuel filler neck or access panel, and is secured by means of metal buttons or snaps inside the compartment. Many high-performance light aircraft, helicopters, and some smaller turboprop use bladder tank. One major downside to this type of tank is the tendency for material to work hardened through extensive use, making them brittle, causing cracks. One major plus side is the ability to use as much of the aircraft as possible to store fuel. So in this, being it is a rubberized item, after some time there is likely to be the cracked, and this crack may cause the leak of the aircraft. But the positive side is that wherever you want use, and you can accommodate the extra fuel on this. Combat aircrafts and helicopters generally use self-sealing fuel tanks. These are the safety fuel bladder. Okay, how these fuel bladders are fitted here. It is shown here, and here also it is fuel bladder is shown in the diagram. Fuel system of aircraft and spacecraft: light plane, Piper, Tri, Pacer. Here this you can see vented filler cap. Here you have the gravity flow fuel tank. Engine carburetor is here. Engine priming pump, fuel tank, selector valve, all are here. This full fuel system of a gravity fuel system is shown here. Another one is the jetliner. We have here reserve tank 4, main tank number 3. Here also 1, 2. Here we have the center wing tank. Okay, so like this we have different tanks. And if you see about the space research rocket X-15, here we have the pilot seat, we have the oxidizer, we have the fuel tank, we have the engine here. So different types of aircraft, we use the location of the fuel tanks are different. We have also seen that we are using some fuel in the aircraft, and different countries use different types of fuel grades. Fuel for aircraft with turbine engine is classified as Jet A, Jet A1, Jet B. Jet fuel is basically kerosene and has a distinctive kerosene smell. Since use of the correct fuel is critical, dye are added to help identify the type and grade of the fuel. These 3 types of fuel all are kerosene, but they have some special properties. So we should able to identify that which fuel is used here. So these aircraft use avgas 80, avgas 100 and 100 LL. Although the avgas 100 LL performs the same as grade 100, the LL indicates has a low lead content. It is called the low lead content. Here this you can see avgas 80, like A, this is the A1 and this is the B. Avgas 80 is red in color, avgas 100 is green in color, avgas 100 LL is blue in color, Jet A is colorless or straw. And this is on pipeline, these colors are pasted on the pipelines so that the maintenance person or the person who is working, he or she can able to identify which type of fuel is used. Now I will talk about the fuel safety. It is very much important that safety is because fuel is very much flammable. So proper design and construction of a fuel tank plays a major role in the safety of the system of which the tank is a part. In most cases, intact fuel tanks are very safe, as the tank is full of fuel vapor air mixture that is well above the flammability limits and thus cannot burn even if an ignition surface were present. Bundled oil tanks are used for safety, storing domestic heating oil and other hazardous material. Bundling is often required by insurance company rather than single-skinned oil storage tank. Several systems such as battle jacket and the rubber bladers have been developed and deployed for use in protecting from explosion caused by the enemy fire. The fuel tanks of military vehicles is the fuel tanks of the military vehicle in conflict zones. For stationary fuel tanks, an economical way to protect them from hazards like extremes of temperature and vehicle crashes into bury them. However, buried tanks are difficult to monitor for leaks. This has led to concern about environmental hazards of underground storage tanks. Precautions before refueling means whenever we are filling the fuel, what type of precautions an individual has to take. Personnel engaged in refueling shall not carry lighter or other means of ignition items and shall not wear footwear with exposed iron or steel studs. GPU must be positioned at least 6 meters away from the aircraft fuel coupling and venting points, hydrant valve and other refueling equipment. Precautions prior to aircraft refueling. Aircraft operators shall appoint a refueling in charge to supervise the refueling procedure and handle the refueling process, including irregular situation. The refueling in charge shall identify himself to the into-plane refueling operator. Fire extinguishers and an aviation fuel system emergency shutdown valves are available at readily accessible position at the aircraft parking stand and all the refueling vehicle. Regular emergency response training should be conducted to ensure the refueling crew is convergent with the contingency procedures in airport fire contingent and the apron control center for spillages of the fire. Okay, so just I want to explain that the first and foremost precaution for this thing, we should not carry any lighter or matchstick or any other thing. Also, the shoes should not have the nails on that. If nails are there, the friction of the nail and the body can generate some spark, and this spark, if you are near the fuel tank, there are chances of the fire. Also, we have to make sure that during refueling, a supervisor or in charge to be nominated. He or she should be properly qualified. He should make sure that some people are positioned with the fire fighting equipments, firefighting extinguishers, and also the shut-off valve should be very near, as and when some emergency, the shut-off valve to be closed. Also, the airport fire contingent should be informed, apron fire team to be informed during the fueling operations. The fueling in charge shall ensure that the aircraft wheels are adequately chalked before refueling start. A refueling zone extends not less than 6 meters radially from the filling and venting point of the aircraft and from the hydrant valve in use of the refueling is established. A refueling zone radiating from the tank vent of the bowser during refueling, and the refueling does not take place if hot brakes occurs after landing and observed until the brakes have been cooled to the reduced potential fire danger. The aircraft refueling vehicle hose, coupling or the nozzle filter, tunnel or any other appliances through which fuel passes shall be effectively bonded to each other. Therefore, filler cap are to be removed and shall not be disconnected until the filler cap have been replaced. So there should be electrical earthing, the bonding, all the caps should be proper earth. These all things should take the proper precautions. Make sure that there is no any venting point or any other fuel points 6 meters from where you are refueling the aircraft. Safety risk and the hazards. The primary risk is unintended ignition of the fuel vapor, which can occur by a single spark. A sufficient quantity of fuel vapor to create a high risk of ignition may result from spillage arising from procedural error, leaks, aircraft tanks venting, or failure of the precise fuel links or their couplings. Now, what are the threats? Fuel leak is the main threats. If the fuel is leaking, it may cause the fuel fire, and the pressure of your fuel tank will be, or your pipeline will be disturbed. Fuel imbalance, the fuel of left wing and the right wing should be balanced. It should not go from one side it is going more, from another side it is going less. It will cause the imbalance of the aircraft. Fuel freezing, if any moisture is present in the fuel, and just now I have told that 14% of air in ATFK can be trapped in a sea level condition, and as and when you go up, this vapors or the air which is trapped, it is start boiling and it is coming out. So this moisture which is available in the fuel, due to the cool weather, it may freeze, and this can block the filter, this can block the nozzles of the fuel ejector. So we should try that the fuel should be free of moisture, and also if it is not possible, some heating arrangement on the fuel should be done, and this is done by the trapped air or bleed air which is taken from the engine. Electrical failure may limit the availability of the fuel pump and the other things. So What are the effects? The fuel leak from an engine can often be resolved by shutting down the affected engine. A tank leak due to the rupture in the tank will result in the loss of some or all of the fuel in the tank. If a fuel line is ruptured, it could result in some fuel being unusable. An uncorrected fuel imbalance can lead to difficulty in controlling the aircraft. A pump failure could result in the inability to use the fuel in the affected tank. This may be mitigated by a second or even a third pump in the same tank. Fuel freezing can lead to loss of power due to fuel starvation and potentially can result in engine failure. In the event of electrical failure, some or potentially all fuel tank boost pump will be lost. In most aircraft, gravity fuel feeding is only possible. From some of the fuel tank, descent may be required to comply with the maximum allowable fuel gravity feed attitude. Diversion may be required due to unusable fuel. Next class, I am going to cover fuel inerting system, principle of operation, oil tanker, aircraft, other modes, uses, potential risk and health concern, fuel tank and safety, maintenance program and practices, possible problem areas. These are the references. Aircraft systems, mechanical, electrical and avionics systems by Moyer and Seabridge. Design and development of aircraft systems and introduction by Moyer and the Seabridge. These are the two references which are very good books. And any questions you are welcome to ask to me, and I always give my email. So ydwidi@gmail.com. This is my email. You are welcome to ask. And I also request to like and subscribe this channel for boosting up my morale. Thank you very much for this and enjoy the day.
Like, share and subscribe. Hit the bell icon for more updates.